Alright, welcome to the Algebra 2 YouTube channel for How High School. We're going to start out with Notes 1.1. Let's start out with this simple review stuff. We're just trying to remember what math is, what we're doing, all the little stuff. Alright, so this first problem, negative times negative 7.7. We know because we have a sign right in front of parentheses that here we're using multiplication. So negative times negative makes a positive. So all we're left with is 7.2. That's our answer. Let's look at the next one. Same sort of thing. Negative times negative makes a positive. So we have 1 plus 3, which gives us 4. Next one, similar, but now we have positive times a negative. Well, positive times a negative makes a negative, so we have negative 9 minus 4.5, and that gives us negative 13.5. You can use your calculator to help you out on this stuff, but we need to make sure we know the rules without using a calculator. Alright, down to the next one. Alright, what's going on between these sets of parentheses? Well, it's multiplication. So, we have a negative times a negative, so that makes positive, and 3.4 times 2 is 6.8. Alright, next one. What is that sign right there? That's division, so we have negative 15 divided by 3. Negative divided by a positive is a negative. 15 divided by 3 is 5. Now this last one maybe takes a little more thought. We've got some fractions here. What looks complicated about this? We have a plus and then a minus right here. That minus in the negative in the denominator just looks real funky. So we're going to get rid of it. What's a positive times a negative? It's a negative. So we have negative 2 over 5 minus 3 over 5. Well, what's common right here? The denominators. Since they're common denominators, we can write them all over 5. So there's our common denominator, and then we just put the numerators up there together. Negative 2 minus 3 is negative 5 over 5. Negative 5 divided by 5 is negative 1. There's our answer. I always appreciate when people box their answers in, circle them, something to where I know where the answer is on your homework. That'll help me out a lot. So, there you go. Hopefully you feel good about this basic math stuff. You're going to have some of that on your homework. Now, the rest of the first part of these notes is really more vocabulary. We're just remembering all the right terms so that when we have conversations in this class, we're using the correct words and we're using them properly. So in algebra, we deal with real numbers and imaginary numbers. Now imaginary, yeah, it's as complicated as it sounds, but don't worry about that yet because we won't use those until chapter 5, so that's around Christmas. There are several tips, so hold on, let me say this. We're going to focus on the real numbers up until Christmas and even after that, but real is what we're dealing with. So there are several different types of numbers within real numbers, okay, so real is like the big overarching category, and then there's categories within that. The smallest, most exclusive category is natural numbers. I'm going to put a 1 by it because this is like our first, most basic category. Natural numbers. These are counting numbers. If I'm going to count the people in our class, and I start with 1. 1, 2, 3, 4, so on and so forth. So natural numbers start with 1, and then they're everything that's past that. Okay, 1,072,000 is a natural number. Now it'll take a while to get up to that, but that is a natural number. Alright, the next category, we're actually going to skip over to the side here, is, this is category number 2, is whole numbers. Now, whole numbers include all those natural numbers. We're just going to make our group a little bigger. We're going to include some others in our group, okay? The other number that we are including is 0, okay? So whole numbers are all the natural numbers, so our counting numbers and 0. So here we start with 0, and then we keep going from there. Forever and ever, we keep going. Now, looking at this, if I ask you what group the number 2 is in, what do you say? You say natural and whole number. Very good. What about 0? It's only in whole numbers. Alright? So, some of them are in more than one category. Some are only in one. Some are in lots. But we're going to keep going and add some more categories. Okay? The third category is called integers. Now, this includes all the natural numbers and whole numbers, plus their opposites. And I'm actually going to mark out natural right here and put whole. That is really more correct. I need to change that. Okay, so we've got all the whole numbers, 2, 3, so forth. I skipped one for some reason. But what are their opposites? What does that mean? It means they're negative. So -1, -2, -3, so forth that way. Alright, so we kind of doubled what we're including. All the positive numbers, all the negative numbers. It's bugging me that 1's not in there. Alright, so now we have 3 groups. We started out small and exclusive, and we've added some to our group every time. Let's go even further. In our biggest group, so it includes everything we've already talked about plus some, are called rational numbers. So it includes natural, integers, all the positives, the negatives, all that, and 0, plus all the numbers that can be written as quotients. Quotients is talking about division problems, alright? So like 3 divided by 2. Well, what is that? That's a fraction. Okay, so basically, any fractions that are made up of integers, not decimals, integers are rational numbers. Think of it. What are the first 5 letters here? What do they spell? Ratio. Well, a fraction is a ratio. Alright, so those are rational numbers. Now, something that you need to remember for all of this class and forever beyond that is that the bottom of a fraction, which we call the denominator, cannot be one specific number. What is that number? It's 0. The bottom of a fraction can never, ever, 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 ever be 0. If you try to put that in your calculator, just do like 1 divided by 0. It comes up with an error. Okay, you can do that over and over and over, and it'll never work. I always say that if you do it too many times, your calculator's going to blow up, your paper's going to catch on fire, the whole school's going to burn down. You cannot divide by 0. Okay, back to what we were talking about. So fractions are rational numbers. Also, we've got some decimals as rational numbers. We've got 2 different types. We've got terminating decimals and repeating decimals. Now, terminating, what does to terminate mean? It means to end, to stop, all that. So these are decimals that have like a specific stopping place. Like 1 divided by 8 is 0.125. Boom, it stops, it's done. Okay, that's easy to deal with. It's great. So that's terminating, that's rational. Now, the other part are the repeating decimals, like 1 over 3. Well, what does 1 over 3 equal? If it equals 0.3333, keep going forever, or the other way to write that, 0.3 with a line over it. It repeats, it goes on and on, okay? So those are also rational numbers. If you think about it, someone who is rational, you think of them as they think clearly, they make sense, you know, they're concise, okay, they're easy to deal with. So all rational numbers are kind of easy to deal with, especially these up here. They're really easy to deal with, but fractions, pretty good, terminating decimals are good, and repeating decimals, those aren't too bad. Okay, so all rational things, easy to deal with. Now we talk about their opposite. Their opposites are these are irrational numbers. I'm just going to put the pound sign. That means numbers. Alright, irrational numbers. Think about somebody who's irrational. They're kind of crazy. They maybe talk a lot, go on and on and on, and they don't make sense. They're very hard to deal with. Okay, that's how irrational numbers are. These are numbers that cannot be written as quotients of integers. That means they're not fractions. Okay, so no fractions. So what are they? Their decimals don't terminate or repeat. That means they go on and on and on and on. What is a famous number that goes on and on and on and on? Pi. It goes forever. Okay, so that is an irrational number. Now, other irrational numbers come from when we take square roots of something that's not easy to take a square root of. Okay, so if a positive rational number is not a perfect square, like what are perfect squares? 25, because square root of 25 is 5, or 64, things like that. So things not like that, then its square root is irrational. Alright, so like, what can we not take the square root of? 2, or 5, or negative square root of 61. Okay, all those things are irrational numbers. They're hard to deal with. So let's take all these numbers and put them in this diagram just so it's easier to think about. Let's start with our most exclusive category. It has the smallest number of members. That is the natural numbers. Okay, what are the natural numbers? Counting numbers. We start with 1, 2, 3, so on and so forth. Now, if we get a little friendlier, include some others, what do we get? Our whole numbers. And that's all the natural numbers plus 0. So we have 0, 1, 2, 3, so on and so forth. Now, let's be more inclusive, include some others. We're going to include the negatives. So that means our category is the integers. Okay, so that's all the whole numbers. And they're negatives. Negative 1, negative 2, negative 3, so on and so forth, both ways. Alright, so that group's a little bigger. Then, on the outside here, we've got rational numbers. Okay, so we've got lots of other things that fit into that category. We know that, remember ratio, so we're talking about fractions. So like 1 over 2 or negative 5 over 3. Those are rational. What about decimals? We had two kinds of decimals that are rational. Whoa, sorry, didn't mean to do that. Okay, we had our terminating decimals like 0.5 or negative 1.125. We also had our repeating decimals like 1.3 repeating 3 or 2.25 repeating 25. Okay, those go in there as well. But what's also rational? Everything we already mentioned. Okay, so numbers like 10 and negative 30 and crazy big numbers, 1,000, 3,000, all that fits in there. Okay? Oh, yes, we also have our perfect squares, like square root of 81. Remember that one? That's 9. So we wouldn't write it as square root of 81 because that's not simplified, but it's good to think about just to know the perfect squares fit into rational numbers. But the opposite of that is irrational. What's the famous irrational number? Pi. Okay, why is pi an irrational number? Because its decimal goes on and on and on, like 1.2345 6, 7, 8, 9, 10, 11, forever and ever and ever. It keeps going. Okay, that is irrational. What else are irrational numbers? The square roots of not perfect squares, like 6. Or negative square root of 20. Okay, things like that are irrational. Okay, I think we're good on numbers. In the categories, just remember, if I ask something like, what category does the number 30 go in? Well, think about which is the smallest group it goes in. Well, it goes in natural numbers, which means it's also whole, also integer, also rational. But like the number 0, the smallest group is this whole number, so it's in there, it's also in integers, and it's rational. But like 3/4, that's only rational. Negative numbers are only integers and rational. Okay, remember that they can be in more than one category. Alright, unless they're fractions or these decimals down here. Now let's go to the next page for some simple other things. Okay, we're just going to think about ordering numbers. Which ones are smaller, which ones are bigger. If I ask you, which is bigger, 10 or 20, you can automatically, hopefully, tell me that 20 is bigger. But there's some other things that aren't so easy to automatically know. Like if I ask you, which is the biggest number out of this? Well, these two are both positive, but I don't really know what the square root of 5 is, so I can't be sure. Well, that's when calculators are very handy. Okay, so we're going to make all three of these numbers look the same. So let's make them all decimals. Alright, -3/2 is -1.5 as a decimal. 1.7 we already know is a decimal. And square root of 5 is like 2.24, I believe. Now here we can kind of tell, but let's just practice with a number line. I know you remember how to do this, but let's just remember together. Okay, so we've got 0, 1, 2, 3, and we have our negatives. Okay, and then the last one, 2.24, is right there, and that's square root of 5. Now here we can very easily see which is the biggest and which is the smallest. So, number lines, though they seem a little elementary, basic, they're very helpful in helping us visualize these things, especially when we get negative decimal numbers. Those just get a little difficult, but we can do it with a decimal, or with a number line. Now we're going to compare these numbers. So basically we're going to replace this and with one of these symbols. What are these symbols? There are inequalities. Symbols, less than, greater than, but which one's which? This one is less than, and the second one is greater than. Now there are lots of different ways to remember this. Kind of everybody has your own. I'll just tell you mine just in case you are looking for an idea. I look at whatever end comes first. If it's the small end, then it's less than. If it's the big end, it's greater than. Alright, so the smaller number needs to go first over here. Here, the bigger number needs to be in front of it. So, let's figure out what the negative square root of 0.25 is. Try that in your calculator. So once you've put it in your calculator, you should get that square root is negative 0.5, and the other one is negative 0.1. Alright, so those maybe are a little confusing. It's hard to visualize. So let's just make a number line here. Okay, here's 0, here's negative 1. Since we're dealing with negatives, I only need that side. Where the negative 0.5, so that goes right in the middle. Okay, that's our negative square root of 0.25. And then our negative 0.1 is really close to 0. And that's negative 0.01. Okay, so looking at this, the bigger number is the one most to the right. Okay, so this one is bigger, which means this one's smaller. So what do we replace the and with? The smaller number comes first, so we're going to replace it with a less than. So negative square root of 0.25 is less than negative square root of 0.01. That is our answer. Alright, try the next one on your own. Okay, pause the video, try it on your own, and then come back and check it. Alright, here's the answer if you want to check. I found that we needed a greater than sign because the first square root that we had of the 0.08, the negative square root of 0.08, ended up being closest to 0, which meant it was bigger. Alright, because it was the most to the right. Okay, this number was most to the left, so it's the smaller one. Smaller end faces the little number, big end faces the bigger number. Alright, so you should be able to do your worksheet now. You've got several different parts of the notes. Come back and reference this if you need. And of course, come ask questions in the morning if you need help.